Good morning. In the last classes, you studied what is diode, how diode is formed, types of diodes and types of operation. So, those things you studied in the last classes. In today's class, we will discuss rectifiers. You know that rectifier is a device which conversion of AC to DC, which is nothing but the rectification. The process of converting AC to DC, either voltage or current, this process is nothing but the rectification. The device which performs that process, rectification process, rectifier. There are three types of rectifiers: off wave rectifier, full wave rectifier, bridge type rectifier. First one, we will discuss off wave rectifier. Before going to consider the rectifier, here we are using transformer. The transformer, there are two types of transformer. One is step up and one more is step down transformer. Here the name indicates that step up transformer. We are increasing low voltage to high voltage, which is nothing but the step up transformer. In step down transformer, we are reducing the voltage level from high value to the minimum value, that is maximum value to the minimum value, required minimum value. That is nothing but the step down transformer. Step up transformer, step down transformer. For rectification process, we are using diode as a component. Therefore, we require only lesser voltage. Hence, we are considering the step down transformer for the operation. Hence, here we are converting high voltage of 230 volts to the required 1 volts, 2 volts or 3 volts or 5 volts, like that. This is nothing but the step down transformer. So, step up transformer are used in residential area or in industries to increase the value of the voltage. 230 to 440, again required high value of the voltage, which is nothing but the step up transformer. The next one is off wave rectifier. Here the main operation is converting AC to DC. So, this is the diagram. We are applying the AC. This is nothing but the transformer. We are using step down transformer. This is the load resistor RL, this is the diode D, and input supply, AC supply. We are calling this as V in, input voltage. So, this is the transformer. We are using step down transformer. This is primary, this is secondary of the transformer. This is the diode D and the load resistor RL, voltage across the load resistor RL, we are considering the load voltage value. So, consider these are the point A and I will consider this as point B and I will denote this as point D and this is point E, okay, for our reference analysis. So, we will go for waveform. The input is applied is AC. So, this is nothing but this is the AC input voltage. We will call this as V in, input voltage. The maximum voltage is Vm, the input voltage is V in and the maximum voltage is Vm. It is positive above the axis 0, above the axis is positive and below the axis is negative. I will consider that as minus Vm. Next is we will consider voltages and currents. This is with respect to time. I will call this as omega t. This is 0, pi, 2 pi, 3 pi, 4 pi, etc. So, this is the waveforms for input voltage V in, the maximum voltage which is Vm and this is minimum is minus Vm. This is the current, we represent that by IL and the maximum value of the current is represented by Im Similarly, VL is the voltage across RL, and Vm maximum voltage of the VL. Similarly, Im is maximum current of the IL which is flows through the circuit, and also the RL. We will discuss the operation of off-wave rectifier in detail. Let us consider that the input voltage is AC, which is sine wave. So 0 to 2 pi is the one cycle. So out of that, 0 to pi is the positive off cycle and pi to 2 pi is negative off cycle of the input voltage. Let us consider we are applying the positive off cycle voltage, which is 0 to pi, similarly 2 pi to 3 pi, etc. We are applying the positive voltage, and this positive voltage makes the terminal A and terminal B as positive and negative alternatively. That is 230 volts is reduced to required 2 volts or 3 volts, and this voltage makes the terminal A and B are positive and negative alternatively. The positive potential which is connected to P type of the diode, and this one type of the diode is connected to the negative terminal because through the resistor RL. This diode becomes forward bias. In the forward bias, we are considering the circuit is closed or switch is closed. Now the diode acts as a switch. When it is forward bias, the diode acts as a switch which is closed switch. I will replace this diode by a closed switch. Closed switch, the diode D, which acts as a closed switch because of the forward bias condition. Therefore, due to this voltage will create the current and which is flows in this direction. Okay, which flows in this direction. Therefore, the current which is flows through the RL, the load resistor RL. Across the load resistor RL, we are getting the drop, which is nothing but the voltage drop, which is VL. VL is nothing but the voltage across the load resistor, or we are calling that as output voltage. Now consider that during this IL is the current, the load current which is flowing through the load resistor and also in the circuits, and which starts at A and ends at B, negative potential. During positive off cycle of the input voltage, the current flows in the circuit. We are getting the current IL for positive off cycle 0 to pi, 2 pi to 3 pi. Then the same current is flowing to the load resistor RL, and across that we are getting the load voltage, the VL for positive off cycles. In the positive off cycle, the diode is forward bias, acts as a closed switch. The current flows through the circuit and also through the load resistor RL. For drop across that RL, VL. Let us consider for the negative off cycle of the input voltage. Let us consider now off cycle of the input voltage, which is negative cycle of the input voltage, negative input voltage, that is from pi to 2 pi, again 3 pi to 4 pi, that is the negative off. This negative voltage which is appears at the primary of the transformer, which is reduced to a required value. The terminal A and B are negative and positive alternatively. This terminal A is negative and terminal B is positive alternatively. This negative potential linked to P type of the diode, it is nothing but reverse bias condition. In the reverse bias condition, the diode is acts as an open circuit or open switch. This is represented by a open path because it is reverse biased. Now the voltage appears here, the negative voltage, and there is no continuous path here. Therefore, the current will not flow through the load resistor RL. The current IL is 0 and the voltage VL, there is no current means there is no voltage. Therefore, I will consider this as 0. VL is also 0 and IL is also 0. We can represent the waveform such a way that from pi to 2 pi, 3 pi to 4 pi, the current is IL is 0. This is 0. No current flows to the circuit because it is open circuited. Therefore, there is no current means no voltage across the load resistor RL. Therefore, the voltage is also 0. In this negative off cycle, the current and voltages are 0. Hence, we can say that the off wave rectifier is rectified output is only for the positive off cycles for this circuit. So, only it gives the rectification process only for the positive off cycles. And during negative off cycle, the current is 0 and voltage is also 0. Hence, this is called as off wave rectifier. Off wave rectifier. You can ask like this. So, why rectification is performed only for the positive off cycle? Why can't for the negative cycle? Yes, we can perform for the negative cycle also. Small changes in the circuitry which gives negative off cycle should be rectification and positive off cycle should be clipped off. We can see here, you change the diode like this. This is the circuitry for negative off cycle of the input voltage. Now, I am considering negative voltage. What will happen? We will see. Consider that the input voltage is positive off cycle of the input voltage for the cycles from 0 to pi and 3 pi to 4 pi, positive off cycle. This is step down, it is reduced. Again, it is the secondary of the transformer, and the terminal A and B are positive and negative alternatively. This makes this positive voltage N type of the diode, then this becomes reverse bias. This becomes reverse bias. Now, what happens in the reverse bias? The diode becomes open switch. So, it becomes open switch. It is reverse bias means open switch. No current flows to the circuit. Therefore, I will call this as current is IL equal to 0. Therefore, VL is also equal to 0. Now, from 0 to pi, no current flows to the circuit. So, again for the positive off cycle 2 pi to 3 pi, no current flows to the circuit. Again similarly, the voltage is also 0. The voltage is also 0 for positive off cycle. Now, let us consider for the negative off cycle. The negative off cycle which is given to the what? Step down transformer, which reduces the voltage for required voltage, and this negative voltage of the input voltage which makes the terminal A is negative and the terminal B is positive alternatively. This makes negative voltage is connected to N type of the diode, so this becomes forward biased. If it is forward biased means it acts as a closed switch. You can call this as closed switch. The current which is flows the load resistor RL. The current introduced in the circuit, hence the current for the negative off cycle. Similarly, when current flows to the circuit, then the voltage is also developed, and which is nothing but what? Output voltage, which is VL. VL is nothing but the drop across the load resistor RL. The operation of the off wave rectifier during positive off cycle and negative off cycle. Here also the output current and output voltage which is obtained only for the off cycles of the input voltage, hence the name off wave rectifier. We will define some parameters of the rectifiers such a way that the current and voltages expressions. So, we will consider the voltage is Vs, the secondary voltage which is appears at the secondary of the transformer. Vs is Vm sin omega t. Similarly, we are writing the current, it is I naught. We are representing this IL also, the load current or output current both are same, which is equal to Im sin omega t. Therefore, where Vm and Im are maximum value of the voltages and currents respectively. Vm is maximum voltage and Im is maximum current. And why we have written this as sine function means it is continuously varying function, AC function. The rectification is not 100%. We are getting, therefore, we can say that the rectified output is not pure DC, it is pulsating DC. It is called as the pulsating DC. The pulsating DC means the DC value of the rectifier which has some AC value also. That is why it is called as a pulsating DC. Ripple means AC component which are not required from the rectifier output, but it is present in the rectified output, which is called as the pulsated DC. The expressions are DC value of the current, DC value of the voltage, and rectification efficiency. Efficiency is good or not, like that. We have to estimate those things by using the efficiency equations. Again, we are going for power. The first one, we are considering DC value of the current. That is represented by IDC, which is DC value of current for off wave rectifier. IDC is given by a notation, the ratio of area under one cycle of I naught or IL by the base. The base is considered as the entire period of the cycle 2 pi, and area under one cycle of I naught means we have to consider the entire value of the I naught from 0 to pi, that is off cycles. Integration of 0 to 2 pi I naught d omega t throughout the time period, dividing by the base 2 pi, the entire cycle. 2 pi is a constant. I will take this as outside. I can write this as 0 to 2 pi I naught is Im sin omega t, that is the standard form. Im sin omega t d omega t, and this is constant 2 pi. I will take that outside. I can write this as 1 by 2 pi into integration of 0 to 2 pi Im sin omega t d omega t. But you observe that from the waveform, the output is obtained only for the positive of cycle or negative of cycle. Only cycle is 0 to pi values. Therefore, I will call integration as 1 by 2 pi into integration of 0 to pi Im sin omega t d omega t plus integration of pi to 2 pi. First is 0 to pi, pi to 2 pi. Im sin omega t d omega t. The current value in the negative off cycle, it is 0, because the negative off cycle is output current is 0, voltage is also 0. We can write this as 1 by 2 pi, and Im is a constant value, take that as outside. I can write this as Im by 2 pi into integration of sin omega t d omega t 0 to pi only. I am considering this as 0. You can write this as plus 0. So, I am going to integrate this. What is the integration of sin theta? It is nothing but minus cos theta. IDC is equal to Im by 2 pi, this one constant term, and integration of sin omega t d omega t is nothing but the minus cos omega t. I will write this as minus cos omega t, limits from 0 to pi. Now, I can write this as Im by 2 pi, top limit first one, again what? The bottom limit. So, this minus cos pi minus of minus, which is plus cos 0, minus cos pi plus cos 0. I can write this as Im by 2 pi minus of cos phi is minus 1 plus cos 0 is 1, minus into minus plus 1, 1 plus 1, it is 2, that is Im by 2 pi into 2. 2 get cancelled. Therefore, I can write IDC value, that is equal to Im by pi. IDC for off wave rectifier, which is equal to Im by pi. The expression for DC value of the current for off wave rectifier, that is IDC is given by area under one cycle of I naught. We are considering the one cycle of I naught or IL, both are same, to the base, entire area, that is base. Therefore, we can write this as 0 to 2 pi, we are considering entire current So, we have to integrate all the current, that is 0 to 2 pi entire cycle I naught d omega t by the base is 2 pi. 2 pi is constant, I taken outside. So, 1 by 2 pi, 0 to 2 pi, and I will write I naught as standard value, that is Im sin omega t. Im sin omega t d omega t. I am going to split the integration term 0 to 2 pi as 0 to pi, again pi to 2 pi, two values. Im sin omega t d omega t, again Im sin omega t d omega t from 0 to pi one value and pi to 2 pi another value. Therefore, this value becomes 0. This value becomes 0 by substituting the value of pi to 2 pi, the current value is 0. Only we are getting what Im by 2 pi integration of 0 to pi sin omega t d omega t. Hence, we can write IDC equal to Im by 2 pi is a constant and minus omega t the limits from 0 to pi. So, Im by 2 pi into minus cos pi applying the limits, minus cos pi plus minus of minus is plus cos 0. Im by 2 pi into minus plus 1, again plus 1, plus 1 plus 1 is 2, Im by 2 pi into 2, 2 to get cancelled, IDC equal to Im by pi. This is the DC value of the current for half wave rectifier, which is nothing but the Im by pi. Next is RMS value of the current for half wave rectifier, which is represented by I RMS. Similar to IDC value, we are defining this IRMS as the square root of, root means square root of area under one cycle of I naught square or IL square dividing by 2 pi. Square root of area under one cycle of I naught square or IL square by 2 pi. What is the value of area under one cycle of I naught square? I can write this as is equal to square root of integration of from 0 to 2 pi, again I naught square d omega t by 2 pi. And 2 pi is constant, I will take that outside, square root of 1 by 2 pi and integration of 0 to 2 pi Im sin omega t whole square d omega t, because I naught is nothing but the Im sin omega t, square root of 1 by 2 pi, and this is Im square sin square omega t d omega t integration from 0 to 2 pi, 1 by 2 pi and integration 0 to pi plus pi to 2 pi. Im square, and one more thing, Im square is constant, I will take that outside. I can write this as Im square by 2 pi and integration of 0 to pi sin square omega t d omega t plus integration of sin square omega t from pi to 2 pi d omega t. And we know that the current which is 0 for pi to 2 pi. So, hence we can consider directly this as 0. There is no current component in the pi to 2 pi values, and that is 0. That is square, we can simplify this as Im square by 2 pi. Now, we cannot integrate this square function. We have to convert that into half angle formula. What is that? Sin square omega t, which is nothing but 1 minus cos 2 omega t by 2. That is the expression. Sin square omega t, I can write this as 0 to pi sin square omega t as 1 minus cos 2 omega 2 t by 2 into d omega t. That is integration of sin square omega t written as 1 minus cos 2 omega t by 2. 2 is constant, take that outside. I can write this as square root of Im square by 4 pi and here for the integration of 1 minus cos 2 omega t as 1 integration of 1 d omega t from 0 to pi plus the integration of 0 to pi integration of cos 2 omega t. What is this function? Omega t, 1 constant d omega t is omega t only. This is square root of Im square by 4 pi into integration of what? This is d omega t is nothing but the omega t plus integration of cos 2 omega t is nothing but the sin 2 omega t, sin 2 omega t by 2. The limits is from what? 0 to pi. Therefore, I am applying the limits now. I can write this as I RMS is equal to square root of Im square by 4 pi again minus 0, pi minus 0, next plus sin 2 pi by 2, sin 2 pi or sin n pi is what? 0. I can directly write this as 0. Sin 0 is also 0, sin pi also 0, sin n pi is also 0. N varies from 0 to any value, okay, whole numbers. Therefore, I can write this as IRMS equal to, and pi get cancelled, Im square by 4, Im square by 4. Therefore, IRMS value of the off wave rectifier, which is Im by 2, because square root of Im square is Im, square root of 4 is 2, therefore, which is nothing but the IRMS. The root mean square value of the off wave rectifier is Im by 2. So, we discuss one more time. IRMS is equal to the square root of root mean square value. So, root and square value, area under one cycle of I naught square by 2 pi. So, I am substituting the values, that is square root of 0 to 2 pi, that is the limits value for entire cycle, I naught square d omega t to the base. Here also we can consider area under one cycle of I naught square to the what? Base. You can write directly that is as base, IRMS value. So, base is nothing but 2 pi, that is all. So, 0 to 2 pi I naught square d omega t by 2 pi. I am substituting I naught as Im sin omega t, that is I naught square means this whole square, Im square sin square omega t d omega t 1 by 2 pi, that is the constant term I taken outside. Therefore, IRMS value is equal to square root of Im square by 2 pi, I taken Im square constant term outside from the integration term, sin square omega t d omega t. I am splitting the integration terms from 0 to pi to 2 pi. So, this function remains the value and this function becomes 0 because the current is 0 in the negative off cycle. Therefore, this is Im square by 2 pi integration 0 to pi. We cannot integrate sin square omega t. We have to use the off angle formula 1 minus cos 2 omega t by 2 trigonometrical relation, that is d omega t. So, 2 is constant minus cos 2 omega t by 2 d omega and t. 1 d omega t integration, which is nothing but Im square by 2 pi, I taken 2 outside, it becomes 4 pi, 1 d omega t minus cos 2 omega t by 2 taken outside, cos 2 omega t d omega t. So, integration of 1 with respect to omega t means omega t only, minus 2 omega t integration is nothing but the sin 2 omega t by 2. So, applying the limits 0 to pi, we are getting this is pi minus 0 and minus of this becomes 0. Pi minus 0, 0, we are getting only pi. So, pi get cancelled, Im square by 4, it becomes Im square by 4, which is nothing but the IRMS. Therefore, I can simplify this to IRMS equal to Im by 2. This is nothing but the RMS value of the current for the off wave rectifier.